Are we ready? I know I am. So, whether or not you are, it's time for another episode of the Indie Tales Game Dev live stream. Hey, my name is Adam. You are the Pixel Pals. I've already said the name of the show. So without further ado, it's time to go. Welcome everyone to the Friday edition of the stream. Today, we're not doing Insignia. Today, we're chilling out doing some other side projects just because I'm tired and my discipline is low today. So I'm just going to enjoy the day and see how we go. Do I mind? Is that your game, Fake Coffee? So, yeah, today we're going to be working on some new stuff. I want to say before we get into it, it isn't your game, but it's a game you want me to try out. That is a strange request. Okay, I want to welcome everybody who's here in chat on Twitch and on YouTube. I want to welcome It's Nimbles for the most recent follow and Nebuchadnezzar for the most recent Ebenkeneza for the most recent subscription. Thank you so much. It comes out tomorrow. Is this a paid game? If it's a game I have to pay to purchase, that's kind of a little bit outside of the channel points system. You just want me to check out the Steam page? Irma. Okay, well, I can check it out. I'm having a quick look. What is your hope about me looking at this? If this is not your game, what is it about it that you want me to see? Just my reaction to the game? Like, what? Is there anything specific? My input. Okay, I'll treat this like it's your game. I'll just pretend it's your game, okay? So, just raw, complete reactions. Here we go. So the first thing I would say is this capsule art it's not bad. I like how clear the title is, and I like how clear the character is. That's a pretty good set of ratios. I might increase the size of the text, and I might increase the size of the main character. I also feel like the other characters in the back here could they could be easier to read. Like for the capsule, I can see there's like a witch and maybe like a Frankenstein's monster style character and like an electric lightning rod. If the angle of this was more like this, then we could have increased the size of these characters a little bit. At the moment, it's not bad. It reads okay. It reads pretty well. Okay. If I press play on the trailer, let's turn this off and so we can listen. A little bit slow to start, but I'm intrigued. Very quiet. Okay, looks like kind of like flash animation. It's kind of cute. Color scheme's nice. Single color. Okay. That's a pretty clear intro. Like it's like seeing 4 things spread over the world tells me I have to go find those 4 things, which is nice. Nice to put in a trailer. Looks like a point and click adventure. I'm surprised there's no gameplay a minute into the trailer though. Yeah, there's some cool. I mean, the fact that it's like the fact that it's like flash animation means that it's pretty. They have some cool opportunities to do some shots like this that aren't that expensive. Like, you know, showing a character interact and emote in a space is something that's hard to do in a video game trailer if you're just doing in-game graphics. But if these are the in-game graphics, then you can kind of do a lot of that stuff in it. So yeah, like it looks kind of cool. I'm not sure what this is. Maybe a battle system. Maybe it's based on scissors, paper, rock. Okay. Pretty moody. Kind of looks like something that I might expect to see on itch.io, but like a little bit higher production value. So I might expect it to be like less than $10. And I would expect maybe the gameplay to be, 2, 3, maybe 4 hours, depending on, I don't know, room for margin of error in my guess. Irma is here and she has a science fair project to finish. Is your project? Because explosively right. Look through your hometown at this point and click adventure. I'm getting a lot of like Courage the Cowardly Dog kind of aspects to it. Figure out how to find the remains of your project to get them back in time to finish the science fair. Okay, so I'm assuming she's done the science experiment and the pieces have gone everywhere and she needs to find them so she can turn in the science experiment. Nice. Okay. And then Outcast Studio. Okay, so it's like a show on YouTube, I'm guessing. Okay, so it's a cartoon on the web. A little slow paced, but the production values seem pretty cool. The monochrome's nice. Is there no dialogue? Okay, I've seen enough. Okay, cool. Nice. It's not really my thing, for sure, but it's. I can see how there could be an audience for that kind of thing. I was kind of into that sort of emo vibe when I was 13. How would I rate it out of 10? Surely you must be involved in this project in some way, Fake Coffee. How would I rate the YouTube channel or the game? The thing is, it's not really, like I said, it's not really my thing. So because I don't really play games like that at the moment, and I'm not involved with that community in any way, it's hard for me to give it a score because it's clearly for a very specific group of people. It's for like a demographic that's not me, for certain. So like for me, if I was to score it, it would be in the direction of appealing to me and a wider audience. So like I would say, something like that probably deserves voice acting as a major aspect. Even in the game, I would put voice acting. I would tighten the editing quite a lot in the YouTube show, but I would also make sure that the game trailer was edited well as well, especially if it's going to have that kind of, cartoon TV cinematic aspect to it as through the game, like a lot of cutscenes. I would probably spend a little bit more time, I guess, developing the character out to new audiences. It kind of, to me, feels a little bit generic as like you know, emo, you know, sort of Western animation drawn characters. Like the hair over the face is just like a very it's kind of a trope that's been around for like a long time. So I would probably be doing a little bit more to create more personality, depending on what they were trying to do. Or if the main character is not the one with the personality, I would give the world a lot of personality. So I could see there's a lot of heart in that's gone into it. Like the people who've made it clearly are, I would say, the same way I am, you know, motivated towards creating a world for people to enjoy. And within that genre, I guess, of media, there are similar things that I would push myself to do in the direction of like creating a world that has like more intent and more personality into it, so that the audience can, you know, appreciate it more and relate to it more, and whatever it is. So in this case, you know, I would just like keep pushing quality wise. It also depends on like what the goals are. So like if it's a game that's like $5, it's probably, I would give it a higher score than if the same game was priced at 30. Do you know what I mean? I think this kind of stuff is very, the value is very, the proposition affects the value very directly. If this is supposed to be a short game, then and just like a tie-in to the audience, like to the property that the audience already enjoys, then it might be, you know, you might find it an 8 out of 10. I could see that it could be an 8 out of 10. For me, like just seeing it cold on Steam, it might be more like a 4 or 5, just because I have little interest to begin with, but from what I've seen, my interest hasn't gone like up from that initial impression. And I'm very time poor at the moment. So I don't have like, for me, I kind of tend to judge more harshly today than I otherwise would. Like if I was like in my late teens, I might find time to play a game like that, especially on like Miniclip or like Newgrounds. On like Newgrounds, that would have been a free game that I would have just played on like a Wednesday afternoon. You know, like Pico's School and other games in that space. There's a friend of mine, Casper, made a series of games on Newgrounds that are point and click adventure that have a very similar vibe to this. You might like them. The problem is I don't know what the name of the series is. I don't think it's called, it's not, it's like something damned or like one sec. It's not cursed. Damned. Condemned. It might be condemned. Okay, I found my friend. No. I will find this game. See if I can find it. It is a point and click. And I want this to be sorted by score. I think it would have a good score. Maybe not score, maybe like views. It was really popular back in the day, I think. Yeah, it's not Picos. It's not Journey of Remus. Reincarnation. He worked on this series. Where is the search? Dude, these are... There's so much AI slop. Anyway, this is the series. And it's got that same kind of vibe to it. Do these actually load? Or what they do? Oh my gosh. Are we doing this today? Hey, newly twitched out. Welcome. So also in Flash, also point and click adventure. Let's skip that.
Looks like the boys and I had a crazy party. Attention, demons. Riley?
Okay, I don't want to play this right now. But you get the idea. I know there's like an audience for that kind of thing. For me, it's... I don't know. I think I'm too old for it. And the stuff that I'm into today is like, I don't know how do you compare fandoms? Hey Blood Red, thank you so much for the sub. Very hard for me to say, you know, why I like something or why I don't like something, or how to rate something out of 10 based on my tastes when it's so, you know, I know if I went to itch.io, I could find like 100 games that all have like insane play numbers that look like that, kind of like light teen sort of horror, emo kind of vibe. That's very popular today. You know, something in the realm of Cartoon Network, Undertale, you know, something very popular. Friday Night Funkin' vibe, you know, something. Not that that game's a horror game, but there's an aesthetic that's very popular. Like younger Gen Z, early Gen Alpha. All right. So today, what are we doing? Today we're working on this thing that I'm building. I really like Macromedia Flash 8. And Macromedia Flash 8 has this tool that lets you draw in vectors. But when it does that, it kind of creates filled shapes out of vectors. And hey, Fake Coffee, why don't we save it for today? I feel like we spent the first 20 minutes of the stream looking at some stuff that you wanted me to look at. So that's kind of worth one already. But let's do it another day. So yeah, the idea is that what it does is it paints vector like this, so that when you draw, the shapes kind of become filled shapes, and you can continue to draw and they still remain filled shapes, rather than a lot of the time when you're using a vector tool, you are essentially placing points, and those points have a Bezier, they have control anchors and yeah. And so when you have like a weight to this, like a width, it sort of just creates like an edge around a spline, which will not let you do this. You can't have this additive workflow with splines like this, because if I was to draw this and then draw like another one over the top, what I'd be getting is just two splines, right? And over time, they would just become this additive mess of splines. So Macromedia Flash 8 had this really cool workflow where, and I mean, even modern Adobe Animate has this tool, but it lets you treat vector like it's bitmap. So, so what we're trying to do today is I want to work on something that's kind of like an open sourcey version of this. I want to build something that at least is like a proof of concept that you can solve this. And it's not necessarily something that I'll ever work on long term or release or anything. I will keep it open source and I'll let you guys, I don't know, fork the repo if you want. But I think I'm just invested emotionally in the idea of like solving some of these problems. And I used to, a long time ago, before I got into game dev, practice my programming skills by taking on little projects like this. So what I have at the moment is already something, and I did get a little help from ChatGPT last night to get me started on this stuff, but pixel density 2, we don't need that. So what I have is something that lets me draw, and then I get basically a filled shape. So it's close to what I would want, but it doesn't let me do multiple strokes, and I'm not sure I want to solve this way. So I got this far, but in order to get further, I think I might have to write this stuff from scratch. There's some really interesting logic here that I want to sort of introduce you to, and it would be fun to just sort of go through this problem, I think, with you and see if we can solve it together. So here's my thing. Essentially, what we want to do is I want to be able to just scribble as much as I want, right? And for the resulting shape, if I scribble like this and do that, obviously what I would want in terms of control points is a bunch of dots around the outside, filling in a vector shape. That's what I would want. And then if I was to do this and scribble a bit more, I would want that shape to be essentially like added to the previous. So we get a bunch of points like this all the way around the outside. Yeah, that's what I want to happen. And the first step to doing that, the way I see it, is that what I want to do is draw my brush strokes like that, right? Just as a series of points, right? This is where the mouse went while I was drawing. And then I kind of want to do a pass over this that fills it out with extra points based on distance from that thing, based on like a width. So you have like a brush radius essentially, right? This is where you were drawing. This is the radius of the brush. And so you trace around the points, adding more points as you go, basically, all the way around the thing. Then what I want to do is take this and what is kind of sometimes called shrink wrapping or alpha shaping. I want to find the alpha shape of this. And the alpha shape is the answer to the question, if I have a bunch of points in a cluster, what is the shape that best envelops this shape. Now, when we look at this as humans, that answer is not, it's kind of ambiguous, right? It could be this. This would be called the convex hull. So just like, you just like close in around it. But it could also be something like this, if we wanted it to be more fine-tuned, right? This also encapsulates all of the points. So there's some kind of like logic we want to impose on this to turn a bunch of clustered points into just a shape that is the outline of all the points. Okay? And it's not trivial. It's quite difficult to do that. The way that when I was doing some research on this, the way that this is typically done, or at least a favored solution here, is something that's called Delaunay triangulation. And I actually have some experience with Delaunay triangulation. One of my first things that I wrote after I finished my uni degree while I was at work, just as a hobby, was a Delaunay triangulation algorithm. So I kind of understand what this is, but it's been a long time. I wrote that in 2013. So it's been 13 years since I wrote it. And I don't think I'll use that code that I wrote. I think I want to rewrite it. And the logic for Delaunay triangulation, what it is if you have a bunch of points, Delaunay triangulation says, what is the most straightforward way that I can turn all of these points into triangles? And by straightforward, I mean make all of the triangles as equilateral as possible. That's how you would connect them, right? You wouldn't connect them like this. That's kind of weird. I mean, you wouldn't do that. It just doesn't feel right to connect them this way. Something's like off about these triangles. It's just not like, something's like not, I don't know what the word is, like meshed. Like if you were trying to optimize a mesh, you would want each of the triangles to be as similar sized and as even as possible. So you would do it this way. And the logic for what that is, hey Magnus, thanks so much for the sub. The reasoning behind this is, if you were to take 4 points and consider whether to connect them this way or this way, for any 4 points, there is a connection for which the circles that are on this, like the circumcircles, you call them, as in the circles that run along the ring around each of these, don't contain any other points. So if I was to do this and then draw a circle whose perimeter passed through these points, that circle would contain this point, right? Because I'm trying to run along this triangle's points, right? So I have a circle, the circle goes bing, bing, bing. It's probably quite large, it'd be like this really. And that contains this point, so this is wrong. Therefore, you would take this away and you would try it this way. And now this circle has no points inside of it, and this circle has no points inside of it. Therefore, this is a Delaunay triangulation. This is a proper triangulation because there's no internal circles that contain any other points. And that's true. That will be true for any set of 4 points in a correct Delaunay triangulation. You will not be able to draw a circle that contains any 3 points in a triangle that contains any other points. It just won't happen. So, the reason why we do this is because if we have a Delaunay triangulation of our shape and we start at one of the exterior shapes, you can move clockwise along the shape and you'll find the outline. I.e., it would be possible then to draw the enveloping shape of this as long as we had a Delaunay triangulation of it. It will be open source when I'm done with it. And I don't know how long I'll spend on it. It's just something that I'm working on at the moment. So pretty good. I mean, this is quite a straightforward algorithm, and it's one that has been well documented, and it does what it needs to do. There are some optimizations that I want to try and bake into this process because I'm using a library that's very non-performant. I'm using processing because I don't know how to write C++, and I want to solve the algorithm for this before I start learning a new language to write it in. It's an external project. It's got nothing to do with Insignia. It's just something that I want to, in a subtle way, I want to do all my production art in this tool. In a tool like this, because if I had Adobe Animate, that might be good enough. But I kind of I want there to be a free and open source version of this thing that I want to exist. So today I want to take some time to do it because I'm a little tired and I don't want to work on Insignia. Hey, Arth Vader, thank you so much for the raid. Welcome. Sup? So, I already kind of solved some of this stuff last night. We will be doing Delaunay triangulation, like this. And what I want to do is use kind of like a quad tree system to determine which points need to be considered part of the Delaunay triangulation set, or just a grid. I'm not really sure whether it needs to be a quad tree, but one or the other. And the way that I want it to figure it out is I never want to connect these dots to these dots. And so there is an optimization I think we can do here where if we take the brush size, let's say the brush size for this is this, right? It's like this big. When I'm drawing, I never need to check a point further away than the brush diameter to know if it needs to be connected. I never need to do that. So when I'm doing the Delaunay triangulation, like if I was to take like a bunch of points, I mean, you could probably do this anyway, but there would be some sort of minimum distance where you can say, hey, I don't want to check to see if this point and this point and this point make up a triangle that's worth doing the Delaunay on, because they're too far away. So I would want to like index these by their position, and an octree or a quad tree is a good way to do that. So a quad tree will say, hey, like let's start dividing this space up into squares, and let's keep dividing until we've reached some threshold. And so the idea would be that you only have to check the neighbor squares to know which ones to try and do your algorithm with. In which case, for every point, you no longer have to, it's not like n squared anymore. It's like n, some number, xn or whatever, or like log n. I don't know what it would be, but something a lot smaller than n squared. And what that will let us do is then have really high density as we're drawing, right? And we'd have all of these points here as we go. We'd have a lot of interior points. There's a lot of mess here, but nonetheless, we'd end up with something that was properly Delaunay complete. So this would give us something that looks like this. My only concern is I still want these interior empty shapes. So I'm not sure if running clockwise is going to do that. I guess actually technically we just need to run clockwise from any points in the Delaunay triangulation that are well, actually I haven't solved that yet, have I? I don't know the answer to that question. So let's do a little concept here. Let's say we have these points and these points, and you triangulate these such that you get this nice triangular mesh all the way around. You know, it looks something like you know what I'm doing here. Whatever. Something that looks like this. How does this point know that it is bordering on a big empty space? I guess what we could do is we could take the triangulation inside of the canvas, and we could divide the canvas into 1, 2, 3 regions. And so all you have to do then is just ask if how do we do this? I think there is an intuitive way to do this. So it's not the culling that I'm worried about. It's more like, how do I know this space exists? Like, I can do the culling in general, but how do I know at the end of the process, after I've culled the thing? I've done this stroke, it did the Delaunay triangulation, I have this ring shape. How does the resulting thing not just go, hey, this is a nice big circle and I'm done? Fills all this in. How do we know that doesn't happen? You'd need for this to also know that it was an outside shape. This interior ring, how does that ring know that inside of it is nothing? I think it would be something like there must be something here. Like, how do we know we're on an edge? I think there's something like, if you take a shape and you run a line through it, you can tell if it's open or closed based on how many times you pass through it. It's like a raycast trick you can do, but that's not really what I want. Hey, Squiggy. The length of an edge maximum just wouldn't draw those inner ones. Yeah, but sorry, maybe I don't know if you're fully across what I'm trying to do. The length of an edge maximum. I know they wouldn't be drawn, but I'm trying to do an operation here where we get this, right? We draw a shape, right? And as we draw, just like what's showing up here, there's like a radius around the points. So I'm filling. But what I want is, as I fill this, if I cross back over, I want this to be empty. And what I want to do at the end of this, the end result of this operation, is not, the complex shape that I drew. The end result should just be the perimeter of the shape that I drew. So I want basically an SVG shape where I have a bunch of control points skirting the inner and outer edges of this shape. And if there were other holes that I left just because of the way that I drew it, I want those to have control points too. So I basically need to track all of the edges and determine whether they're like interior or exterior edges. That's what I would want to be the end result of what would happen if I just went like this and started doing this and, like this and whatever. Like, as a vector, that's what I want the end result to be. Something that's really simple. No, well, I'm starting with that because I think the Delaunay triangulation is a really good way of of determining the alpha shape. So like if I'm drawing this shape, this here, will be a big cluster of points based on the initial like path that my mouse took, plus a bunch of outer points that represent the radius of the brush. So what I'll have is a bunch of points. And then from those points, I will be able to create basically a polygon mesh out of them. And then, like you suggest, the extents of the maximum edge length will cull a bunch of, it'll create a bunch of gaps in it, which will result in something that essentially looks like, whatever. Blah, 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 that looks like this. But then my operation that I want to do is I want to essentially take this shape and delete all the interior points so that I'm left with this. That's my goal. Now, if every shape was like a whole shape, that would be no problem. I could just fill the shape every time by just skirting around the perimeter. But I don't know that this is a circle or a donut when I do that. You can see that the original stroke is a crunchy bitmap. That's kind of what we're doing, Squiggy. We're trying to do like a vector trace. I mean, it's not exactly a vector trace, but it's, we're doing a trace one way or another. I suppose we could just look up vector tracing algorithms and just work off that. Maybe it's as simple as that. And we don't even have to do any of this stuff. But to do a vector trace, what is that doing? Is it just taking the... does it do a vector trace of the whole thing? Like if I'm in... It's a good intuition to just look at how they did it and see like, hey, is this how they did it? So what I like about it is when you draw, if I zoom out, the brush size is always the same. It's based on the screen brush size. If an edge is only a member of one triangle, it's an edge. Ah, that's a really good intuition too. I think that's right. I think you're right about that, actually. No, that's a member of three triangles, and it's not an edge. I mean, it is an edge. It was a nice thought. Not quite right. The edge. Sorry, the edge, the lines. Sorry, not the vertices. Yes. This is only a member of one triangle. Yes, you're correct. You're completely right. You're so right, and I was just misreading. Yes, you're 100% correct. An edge that's on the edge. An edge is defined as only being a member of one face. Very good. So we would just count all of the edges that were only members of one triangle. And then we would group them by edge chains. You basically say, okay, this is 1, 2, 3, 4, 5, 6. You just run along until we meet back at our original point. That's an edge. Now we can say that this is a whole space defined by this edge. We would do the same thing from the next one. So you just walk down all of the shapes until you had no more edges left in your list. Done. Oh, very good. That's right. Very, very good. I think that Flash... I think it has to do this anyway, right? How does this operation, see how I'm like running along all this? It very nicely knows that this is all just one shape now. It just did that. And when it did that, I don't think it traced the existing image. I think it only traced the part that we added. So when I go here and I get very granular and I just do that, it's got to be tracing this stroke and saying, hey, is this the same color as any existing shapes? And then it does a union. Yeah, exactly. As long as they have the same color. That's the beauty of this, is that it's using the color to do that. If I switch to some other color, instead it separates the shapes, which is amazing. It's so cool. But like, what happens if I do a gradient for this shape? Can I do that? If I do a gradient, there's kind of no way then that I can separately draw into it. But holy shit, isn't that cool that it separated the gradient at the same color? Like, it didn't draw the same gradient across this, black to green. It went from like olive green to like the different lightly shaded olive green. So like, it knows, I don't know how, that is wizardry. It knew like what green this was and what green this was. And when I separated it, when I intersected it, it split the shape with the same. Oh. Hey, Yo-Yo Bob, how's it going? I suppose there is a gradient, and that gradient's original position, if I was to, can I do like an ink tool? If I ink this, I would probably find that if I then drew in the same ink, it has the same gradient. Oh, or does it? Oh, it must be offset by the same amount that we moved it. So it's what it's done is it said, hey, this gradient, which was here, like now it would be the same, almost the same, but still not exactly the same. It said, when I chop this, the origin point of the gradient and the outer bound of the gradient still virtually exist relative to this. So there's actually just two gradients now with the same origin point that then paint these two separate shapes. What happens if I do that and I rejoin them? Does that work? I take this, I do this, I grab that, and I go out, and I come back in. Oh, that's so good. So very good. How clever. They know. They know. So you can rejoin them because their gradient property is the exact same as the other gradient property. So there's some color struct or something. And if the structs are equal, then they can merge. And the color includes a gradient option or an alpha or whatever it is. Could be some complex thing that contains, it could be just a flat color, it could be some other aspect, but if all of the properties in that structure are equal, then the shapes merge. Okay. So we're not going to do gradients right now, but it's good to know that. That's how that works. Isn't this fun? This is like, to me, this is as fun as game dev. It's almost, it's up there. I'm not as good at it. Squiggy, you'd probably be better than me. My gut feeling is the underlying logic behind it all is simpler than it seems, but it's just put together so beautifully it seems like black magic. Right. I think you're right. Nothing's ever as complicated as it. But the thing is, if I do this, I wonder if there's any way to like hack around what I've described. Like, I wonder if you have to do this no matter what. I know there is something, I will say, there's something that I appreciate, which is magic, which is if you're doing a bitmap trace, the current zoom level is as like the human eye and the depth of the canvas. You don't have pixels in the canvas. You just have what I'm looking at and the pixels that I interacted with at the zoom level that I'm currently looking at. So since you can't be zooming while you're drawing, you're only working with, a pixel space. If I took a screenshot of this, you're just doing a vector trace on that, which is a lot cheaper than trying to have a virtual, like if this was like in Leonardo, when I do this, I mean, maybe Leonardo does something similar because it's very fast. This is a 1000 by 1000 brush. It just did it. There is some calculating pixels in the background. Maybe that's doing a screen space pass first and then going in and doing a trace at the deeper level. Let's try that. If I go in really close and then look at it, I mean, that was really good. I don't know how they did that. Like Photoshop would struggle. 1000 pixel brush, just scribble as much as you want and it's perfect. Oh, it's a little blurry, but it's pretty good. There you go, then it refined. There has to be some smarts going on that's kind of similar to what we're describing here, where like we don't have to do more than what we can see on the screen right now. And so since the screen right now is like a couple hundred pixels maybe for when we're drawing each stroke, because here's the other question. If I spend a long time drawing, right, the solution that I'm proposing would be less performant the more points I drew, because I would have to do the Delaunay triangulation over lots and lots and lots and lots and lots of points the more I drew. If I sat down here and squiggled for like an hour, I would have millions of points. That was pretty quick. So I'm guessing that it's not doing as complicated of a thing. Yeah, I think you're right. Nah, but if I sat here and just kept going, the Delaunay triangulation of this, you would have to take points for every 60 points per like you'd have almost like a point per 10 pixels or something like that, plus the radius. And you would have to compare that with potentially every other point that was drawn in this process. So for me, look at your CPU when drawing. Well, it would be when releasing is when it would be. It's on the moment of release. So like right now, I literally have something that's doing what I'm sort of proposing, and it does this. So this is, notice when I'm drawing, right? It's doing 1 point every frame. And when I release, it's turning that into a shape, into a vector shape. So the longer I did that, I mean, I guess it's not that many. I mean, this is pretty quick. This is processing. Processing is not great. But it would take longer the longer we did it for. The thing is, and the reason why I kind of feel like I think Squiggy is right, because we don't get this when we do it in Flash. We never get this thing where trying to juke it like that gives us a weird edge, because it doesn't even care how we got the bitmap in the first place. It's not trying to interpret a stroke, it's just taking a picture and doing a pass on that. There's no, you get a lot of these control point hiccups in vector programs when you take like a line and you do that, where you'll get one thing that's where the like one control point's trying to do this and one's trying to do that, and then you have a thing here going this way, so it's going like, hey, like what do we do with this part here? Is that nothing or is that something? If you're trying to sample a bunch of points, you do get little weird bits like that. So I think Squiggy's right. I think you're right. You're such a smart cookie. If I can like speak highly of you for a second, Squiggy. I feel like we have a lot of common interests, but one thing that you have that I did not have when I was your age is you have a very you're not emotionally intimidated by these kinds of things, so you're not making an assumption that the person who did this was some superhuman. You're kind of just thinking in like practical terms. Whereas if I was doing this, I would assume that it needed to be much more complicated than my intuition would let on, and I would go looking for the complicated solution that I expected was there. and I would spend a lot of time wasting my time because I would just think, well, I'm dumb and I don't know how to do this stuff, so someone smarter than me must have done some smart thing, you know? I would just assume that it was harder. But to say, well, how hard could it be? Let's think about it rationally. What would be the dumbest way first? That requires a lot of confidence. So I think that's a good, I think it's a good quality to have, is to be curious in a way that's not giving too much respect to the thing that you're doing. Okay. So let's think about it in that way. Let's think about a vector trace algorithm and do some research on that. Yeah, but like there's something deeper of like I would be prepared to explore it, but part of me would just assume that the solution would be outside of my capability, that I would have to learn something new. Tracing algorithms in pseudocode. Maybe this is good.
I'm going to take you through how we can trace algorithms in this video. This comes up in both paper 1 and they are followed. We have from you pseudo.
Wait.
What a problem. But
no, you described tracing to mean something else. Vector trace algorithm. I think because I see a lot of vector software using tracing, I think it's actually not. I think there is a defined solution. I imagine there'd be libraries for it. That just. What is Bellman-Ford?
Today, I'm going to show you an example of the Bellman-Ford algorithm. After watching this video, you'll know exactly how to Bellman-Ford. Look at the pseudocode. Feel free to pause the exams.
My goodness. This is not a popular topic. Image tracing. Okay, let's have a look. Some programs automate the vectorization process. Example programs are Illustrator, blah, 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 blah. Automated programs can have mixed results. A program, PowerTrace, was used to convert PNG map to SVG. The program did a good job on the map boundaries. Other conversions did not go well. Where are we looking at this? What is image tracing? Background. Vectorization is usually inappropriate for continuous tone images such as portraits. Am I missing something? Yeah. Convolutional autoencoders might be beyond us. All right, we're at the good stuff. Let's start reading. We imagine our bitmapped image to be placed on a coordinate system, such that the corners and not the centers of each pixel have integer coordinates. Let us further assume that the background color of the image is white and the foreground color is black. By convention, the parts of the coordinate plane that lie outside of the bitmap boundaries are assumed to be filled with white pixels. Okay, we now construct a directed graph from our bitmap as follows. Okay, here it is. Let P be a point of integer coordinates. Such a point is adjacent to 4 pixels. Yes, the point is called a vertex. Sure. If the 4 pixels are not all of the same color, if V and W are vertices, we say that there is an edge from V to W. Yeah. So we're really doing like a pass over the entire... I mean, the GPU would be good at this, but we're basically saying it's just a differencing algorithm. It's literally all it is. It's saying, hey, when I draw this, let's say these are pixels. Right, this is 4 pixels. and this pixel is filled in. What it's saying is, hey, if I'm this guy here, this vertex, and I'm heading in one direction, look at the pixels either side of the direction. If there's a difference that's large enough over some threshold, I guess, between the contents of this pixel and this pixel, then we consider this an edge. That's what it's doing. That's the first step. What step of the process do you need bitmap to vector? Well, right now it's the whole step. Bitmap to vector is the step right now. So, oh, that's cool. Let's do that. Yeah. Well, I thought you had the outline points already so we can use it as a vector. I was content to try that, but I think Squiggy had a good intuition that doing the Delaunay triangulation to find the alpha shape, to do the outline tracing is probably not worth doing. I don't have the outline points already. I'm not at that point. And I think this might be quite costly. Well, it might be less costly than this, or I should say, it might be more performant than this, but this has like a flat cost per like the screen size. So this might actually be way better. Let's keep reading. So we have an input image. A raster image is essentially a rectangular table of things. It's a full color RGB. If it's full color RGB, then it's a table of color pixels. Color pixels are triplets of 8-bit, blah, blah, blah. You could run it in a compute shader. We could run it in a compute shader. Medical images such as obtained from computer tomography are usually the tables of 12 or 16, da 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 da. Let's just pretend it's bitmap. That's grayscale, sure. So black is 0, which is this blue color here, and white is 255. Technically, we can already turn it into vectors rather easily. Let's just agree on some threshold. Yeah, and mark the contour of the pixel such that the values exceeding the threshold. So, hey, what we could do, if we wanted to be like really cheesy about this, we could just record literally every pixel we touch. Just put all of them. Just put all of them in a big array. And then do a path trace on the pixels. And we are in control of what like color they are. It's not even about color. It's just like, which pixels did we touch? Right? Like we don't even have to calculate. Yeah. It's literally just, hey, we touched this pixel. You can see it here. It's doing the exact thing we're talking about, right? We touched this pixel and we didn't touch this pixel. And since we're doing it at like a lower res screen like this, like you're just having to make sure that when you do that, you just, yeah. So it probably will be slower the larger the area. But like there's something beautiful because it is screen space, right? So if I zoom all the way out, this is not more expensive. It's the same expensive. The most expensive thing we could do is fill the screen and then draw something this big. That would be the most expensive thing. I wonder if there's something smart it's doing to get in the way of that. So Turning an interpolated image into a contour, we can borrow an idea from the simplest possible smooth contouring algorithm. We'll build an initial border from the source pixels, and then we'll use our linearly interpolated image to find the best place to put each contour point. Let's have a look. This is interesting. How does it know where to put the contours based on this? I guess we'll find out. Contouring algorithm is something that turns your implicit function into a contour. Marching cubes and dual method are the most noted examples. Oh, it's just marching cubes. There's also a simpler algorithm. It may not be as efficient computationally, but due to its simplicity, it can be easily improved to produce smooth contours and not just polylines. I mean, I don't love that, but you know, if we had something that was I mean, that's pretty good. That's pretty good. So outer pixels is the part that's hard to explain. So when we draw, how do we know what an outer pixel is? Right, especially when you cross back over yourself, right? These were outer pixels until they weren't. All of these pixels here along the way, these were all outer pixels. And then we passed over them and now they're inner pixels. What's the goal? I just want to have something that works like this, but that I can extend and just do my own drawing algorithm and stuff with it. Like for example, I want scrubby zoom. There's no scrubby zoom on this thing. There is scrubby zoom on this thing. So I just want to be able to like draw stuff and like iteratively build out this little canvas for my own drawing taste. And other people can use it if they like it. All right, so the algorithm accepts a distance function for input. Oh, clear that. Let's just, oh, this is so cool. This reminds me of the Red Blob games guy. I am other people. Could you record only the outer pixels? And yeah, we've talked about that. So the algorithm accepts a distance function for input. This function denotes the distance to the expected curve for every point on the plane. I'm not sure what that means. The first phase of the algorithm is finding the initial contour. Let's iterate through all of the cells in the grid. If the distance function changes its sing between the neighboring cells centers, we'll place a contour between them. I mean, that feels pretty reasonable. It's about whether or not you've got, what, 50% of a... Yeah, 50% or more in the space. Yeah, open source existing algorithms would be the way. We have an interest here on the channel to explore this stuff. You know, it's fun to learn about it. And I don't just want to copy someone else's work right now. Maybe we'll get to that point, but it's fun to learn. So is this SDF? It could be. We're going to find out. The first phase is to find the initial contour. Let's iterate through all of the cells of the grid. If the distance function... Now, I don't know what distance function means. I don't know what these numbers represent. Like, what is 201, 150, negative 74? I guess the edge represents... It's how far the current pixel is from a red edge, from the contour. The contour is the red line, and things that are inside the red line have a negative sign, and things that are outside have a positive sign. So this is an SDF. I'm learning. That's actually insane. Cool. So the contour is literally an edge chain in pixels. It's just like, it just tells us, I guess, what is it? Edge pairs, like pixel pairs. This pixel and that pixel determines this edge. I don't really know how they store it, but, or just the indices that represent, no, it needs to be edges, right? How does it know? I guess we're gonna find out. For the grid size, D in square, D, I'm not gonna be able to read this. In square on the left, in square above. Draw a horizontal piece if there is a sign change. Draw a vertical piece if there is a sign change. Yeah, but how does it know? How does it know what the sign is? I guess we need to first define the SDF function. SDF function. Oh, another beautiful. Inigo Kies is an amazing. Okay, for those of you who don't know, graphics creators or like math creators, Red Blob Games is amazing for this stuff. They've got a lot of interactive algorithms that describe code. So stuff like what we're looking at here, pathfinding, map generation, that kind of stuff. Inigo Kies is another one. And he does mostly shader stuff, but they all do very cool interactive stuff. So distance functions. Here you'll find a list of signed distance field implementations for some basic 3D shapes. Formulas smoothly combine them together. Oh, but this is like distance from a sphere, which is like the length of the vector from the center of the sphere. This is not complicated. I see. So then you would be doing... So how... I still don't know how we get this delta to know that the edge is here. It's easy to do the math on the length. I know how we would get the value, but how do we know where the line is in the first place? Oh. Wait. So you place a circle and then the squares are the SDF from the circle. Oh, I see. I placed a circle down or a line down, and then these, it just iterates through all the circles and says what is my worst or what's my, you know what it is. Am I in any of the circles? What's my SDF based on that? Yeah, the min. Yeah. I get you. Okay. But the point is, we won't need to do this. Well, what will we need to do? We will still need to figure out where the edges are, and we would do that based on the original thing that we looked at here. We'd be doing essentially this, and the smoothing would start with this. I think I'm following. So SDF is easy. We don't even really need to do that because we already have the pixels that are filled versus the pixels that aren't filled. And so now the question is the second phase. We just jump to this part because we just already have the outer Lego shape. The second phase is attracting the contour nodes to the expected curve. The distance function shows how far every node is from the expected curve, and the direction to shift our node is also detectable from the distance function's gradient. you know what? There's probably... we'll get to it. All we have to do is add a gradient vector multiplied by an inverse distance to every node point. My brain. I think I can see it. I think I can see it. Like this is a gradient of like, if I take, is that what it is? You're just like rotating the edges until this code is changeable. Oh, that's friggin' sick. Sign change border crossing. Let's have a look. The first piece is horizontal. The second is vertical. Bone Circuit says on YouTube, back in the day when you have to do all this on the CPU with the FPU on the side, we deployed a set of code snippets called the graphics gems. I do recall a vectorize.c example showing me a very early bitmap to vector. Yeah, I think we're looking at something that's like that. Sign change border crossing, check to see if there's a border crossing. And then draw a horizontal piece. Draw horizontal on piece number 0 or vertical on piece number 1. I think I need to see this visually. Like my brain, I can I'm trying to understand how we get, let's look at this part here, right? How do we get from this to this? It seems to know like when you say the gradient at that point of the distance field, how do I get that? Like, how do I know, for example, that this, like I've got 40, 22, 61, and whatever that is, 2. Is it just the distance between these two numbers? This, what would be a straight line here, goes more over to the right because of the distance between 61 and 2. Like I think of, I think I understand. I think I understand. This is not that complicated. So in this square, if I take 61 and 2, and I take 40 or whatever, and then like negative 22, if this was what 0 would look like, it goes this way because if this total is like 66 or whatever it is, 62, 40 out of 62 puts you there. And if this is 63, 61 out of 63 puts us here. Is it 12? I can't tell. Even if it was 12. Same. Like it's pushing the edge, which is a vertical edge, further over based on the numbers at the corners. Even if it's not doing exactly that, that explains what I'm seeing. So I think that's right. I'm just gonna guess. that that's what's happening here. Because if I scroll up, that would have been a vertical line dead in the center. There. $61 to $40.22. So I've placed my circle, my point here. And so it's really, we're looking at, it ends up, no, I'm sort of thinking about it like this, aren't I? You basically do a difference in the X direction and the Y direction. I mean, I understand what a gradient is, but it's like, how do I know what's the rise here and what's the run? Like, what am I looking at? Is it the difference between, because like what I would do, if I was doing gradient, I would take this point, which is filled, and like this point here, and I would just draw that. Like that's a gradient to me. I take the rise over the run and I know it looks like that. But how do we know, how are we doing that for a whole number like -2 and 61? How does that get converted into a gradient? I'm not following. Like, I feel like you need at least 2 points to do that. Is it because we take like a hypothetical number here? I mean, that's what this is, right? I think I'm still doing the same thing. You look at the 4 cells around it. So, okay, I'm willing to understand what that means. If I'm here, I look at this, 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 and this. And then what's moving? The edge is moving. So it's... Is it the case that the red edges and the blue edges are on different offsets here? Sorry. The vertices that I'm using to do this red line and the vertices that we're using to do the blue, are they offset by half? Like I'm checking something between this, 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 and this at like these points. Because if I'm checking the 4, I think I understand that like the edge would push. I mean, I guess I would do. I still don't understand, like, what I'm not really following is how these points don't all fall on it. They don't fall. The vertices that make up this point, these points don't fall on the grid. That's what I'm getting confused by. I guess because it's doing like because we're doing like marching cubes or whatever. It's like it well, yeah, like marching cubes, you would have like something that does, you know, you would say, well, this is this and this is this, this is this, that's that. And so you would have like, there would still be a grid being resolved to underneath. But are we not doing that here? Does SDF not have to do that? Because what it looks like to me is that this is just shifting to some other number. So the number of points is the same, and they can be, the points can be anywhere in these grids that make up the edges, or anywhere along the grids. Maybe that's the right way to describe it. So like this, I still, like, I get it. I get you would put it here, right? Let's just break it right down. I would do this, and then I would do that. nudge the point. Sure. As long as I understand what the operation is, right? I'm nudging the points, and I'm nudging them based on... Now, you were saying gradient. For me, it's hard to understand gradient because I'm just thinking an axis plus an amount that I'm shifting by. But I suppose if you take this and this, you get a gradient by how much you moved on the X and the Y. Which I think you can do if you offset it by half. You know, you could say between in here, again, if these are like repulsors and these are attractors or whatever, or like, you know, you just think about it as a ratio thing. I think if I think of convolution, you take the difference between the right and left and you add the two columns. Add the two rows. Yeah, I think I'm a bit lost. I think I'm not following what it is that is moving. Let's clear it again and just draw. So like this, let's look at how many points there are. This is what I don't understand. If I clear it and I draw one circle, right? I get 1, 2, 3, 4, 5, 6, 7, 8, 9. Hang on. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 points. Yeah, there are 10 points here. And if I count the number of digits around it, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 digits. So how do I know which, like, where does the 10 come from? I got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, so there's 10 edges that became 10 edges here. So I know it literally is offsetting the reds by some amount. I'm going to have to do a little bit of copy pasting here because what I'm not getting is how these things overlap. Let's take that. I wish I could see both at the same time. And let's take this. And I want to see for myself how this works. Because I'm a big dum-dum and my brain doesn't work good. Okay, so that's what we're looking at here. Alrighty. So now I can kind of see what's happening. I can see that this point didn't move much. This point moved to here. This point moved to there. This point didn't move much. This point moved to there. This point moved to there. This point moved to there. This point moved out to here. This one moved to there. And this one moved to there. Okay. Now I think I'm following. And you can see that the direction they moved represents, I mean, if I take these numbers, 75 is a bigger number than -15, and these two are pretty similar. So that to me understand, like that helps me understand why. This is 20, 59. This number is really, why is that 59? This point relative to this edge, or what? Why are these two numbers different? 43 and 59. I guess because we're actually drew the circle. So actually this point is 59 away from this point there. So 65 goes to 23. It's bigger. 59 is bigger than 20 and 4, so it goes out. So the larger number affects the direction that it shifts. So like this is 43 and 43. It's perfect. This doesn't move at all. I understand that if you blur this, yeah, I was thinking that myself. If you took like a really fuzzy round brush and you did this, I mean, I'm not doing a good job of that, but I understand what you're saying, airbrush. What the hell's happening here? I understand what you're saying, in that these are now, you know, the more dark they are, the higher the number, the more bright they are. If that's I understand. So let's just keep going back to where we were. So my question is, when a point moves on two axes, what makes it move on both axes at the same time? So in this case, I guess I'm checking this distance and this, and then this and this to get a gradient, which is going to give us this. I get it has to be that, right? So if I was to say, take these values and these values and add them together, and then take these values and add them together, and then divide the horizontals by the verticals, you would get, I imagine, some value between some upper and lower bound, and then you just shift it by that amount. I mean, that's what's happening, right? It must be what's happening. The gradient is a vector x and y separately, yeah, because you'd have the movement on the x and the movement on the y. But how do I calculate how far this should move based on, like, what am I doing with 43 and 1 and 87 and 58? I don't know what a Sobel operator is. I guess, I mean, I still think that this distance and this distance, you just average it. You just sum and divide. The distance here would be like, I mean, is that just 1? I can't tell if it's 1 or not. It's 1. So this is like, this ends up being like 42. And then this is, you know, just shy of 30, 29. So do you take 42 and 29 and average those two, which gives you 30? No, hang on. Like 13? What is the difference? 13? So 6.5 on top of this gives you 35.5 or something like that. And so this moves 35% of the way. Is that what it is? Or something? I don't know what the maximum could be, but 35 is your number. And then you do the same this way. You take the y difference, or you normalize it. So you take the vector, you take 35 on the x-axis, you take whatever this is, let's just say, for argument's sake, this is like 44, and this is like 57, and you say 44, 57 is 90, 101, And then you divide that by 2 equals 55. Nope, 50.5. So it's 35.55. You normalize this, and then you go from 0 to 1 away across. And then this is 35.55. It looks right. That kind of looks like 35 out of 100, and this looks like 55 out of 100. So that's how that works. Cool. Sorry I'm such a dummy. I know it takes me a long time to understand these things. I think sometimes I get caught up trying to understand like what is being communicated to me. And it can be really, like, I don't have a very good grasp of like, I can visualize, and if someone's highlighting the thing that's moving or changing, I can immediately latch on. But if I don't know what's moving, it all just seems like words. It's just like a massive word salad. But now I can see it. That makes perfect sense. Okay. So let's keep going. The third phase is adding curvature. Once again, we'll measure the function's gradient for every node. We'll use the partial derivatives to form a parametric third-degree polynomial. Probably sounds more complicated. The third-degree polynomial is for x and y of the solutions for these systems. If you parameterize the polynomials, it will become this, and then you get this lovely thing here. Okay. For fun. We're doing it for fun. So I don't think that Flash does this. Because at the end, you can see what Flash does. If you take this and then you do this, and then I think it's, you double click this or you click this, you can see the points that come out. You get actual Bezier style segments in a closed shape. Which is what I want. Yeah, it's doing a simplify. So the question is, could we just do the simplify? Same as when you click the button. Yeah, the simplify button. It's just doing it over and over again. I agree. So the question is, do we need to do, does the simplify, if we had a shape, if I have this, is that enough or whatever? Is this enough to just simplify that? Like, can I just throw that at the simplification algorithm and say, that's a control point, that's a control point, that's a control point, that's a control point? Maybe. F? I'm still here. Hello? What's up? OBS says it was all fine. I wonder why it went down. Okay. So, the question I'm asking is, I wonder if maybe we don't even need to do, we could just do the simplify on this. Okay. See you, Merlin's beard. The Ramer-Douglas Perka algorithm. Oh, that is so cool. That is so, I love visualize algorithms like this. Is it the point furthest from the line? Between, yeah, are we just bisecting? The whole thing? Eliminate. Oh no, we're stepping. How did it know to jump to this one here? Let's look at it again. Check all of it. And skip ahead to the greatest distance. Check all the remaining, skip ahead to the greatest distance. Check all the remaining, skip ahead to the greatest distance. I see. So it's doing like a, almost like a, that's so cool. Ah, I love this stuff. I love it. So you're literally saying, okay, we've got 1, 2, 3, 4 points here. And then we're saying, let's do like a bunch of points. So I say here to here, this is my end. What is the point furthest from these 2 points? And that would be this one here. So now I say, hooray, this one. So now my candidate line is this here, and I don't need that anymore. Then I say, okay, now between here and here, what's the biggest distance? If any of them breach some threshold. That was, I think, what was happening there. So let's say the threshold is like this far. So I could say, okay, this one does break, this one does not break, so we nix that. We say, don't care about you, and we go, yep, you're here. So the new line now is this. And then we go, okay, between you and the end, do we have any that break the line? The answer is, let's say yes, it's this one. So now we go like this, and then we do the same thing here. We say no, therefore we get this. From that becomes that. That's fun. Fun to visualize it. Okay, sweet. That seems really reasonable. The challenge is going to be doing it on a closed shape. Because what happens when you have like... I think it needs to be an edge. Even if it's got a seam on it, it needs to be an edge. It can't be a shape. It can't be a cluster of points. It has to be a chain. So let's just say we have this chain, and I'm going to mess it up a little bit here too. I'm going to go a little crazy with it. So the chain that we start with is this. In fact, I'll put it on a new layer. This, 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 and then bring that down. And then, okay, so we can start with anywhere. I'm just going to assume we can start with anywhere. And we go, okay, how many from this to like this one, what is the most extreme point? I guess, like, what's the furthest point from these? I guess it would be this one. So I'll call that the next point. So I have this right now. And then I go, again, I just do the same thing. Let's say my tolerance is like this far. So in this case, the answer is yes, this is way more further out. So now I have this. And then now I have this check with this, and it doesn't meet the tolerance, so it goes away. Then I just do this all the way back to here again. And then I guess this is the furthest one here. So now I have that. This doesn't meet the tolerance check, so I keep that. I do the same thing. I get this one. This doesn't meet the tolerance check, so I do that. Wow. That is just so cool. That is just so cool. How neat. And then I suppose you just do the control points so that they are, you would have some logic, I guess, as to whether or not a control point should be a sharp point or a relaxed point. And then if it's relaxed, you always make it like half, I think the half like the distance of this. You just sort of make them like that or something. I think there's a way. Or you make them 0. There's some way to make, there's like a default position of like control points to make this then now looser. There'd be some algorithm you could check based on even including the points that we threw away or something. There's probably a way to do it. I'm not sure how you would do it. Maybe you would take like the... There'd be some logic where you would say, even though we ended up with a shape that's quite edgy here, the previous shape that we had was one that was a little more relaxed. So give me control points that get me closer to that so that we pass through this thing, even though we're not keeping it. There's some, and I assume, I guess you could average them. You could say, hey, like, let's just say there was like 100 points between here. I suppose it wouldn't matter really, but if you were to average them, that would probably give you something better. Like, how do you know that a zigzaggy? Well, you would average it, right? It doesn't matter because we already simplified. You would just pick a tighter tolerance. Okay. This is so fun. I love that. Okay. Well, I think like we could probably implement everything we've just seen and get something that was essentially this. I'm like so excited because I think we found like 4 different algorithms we can implement. Okay, I'm gonna throw out pretty much everything that we've got and start anew. Let's go fork this out into a new branch and call it shape trace. And now let's go to shape trace and let's get rid of like pretty much everything. So let's maybe do some pseudocode here. There's some stuff here we need to think about. One is like, actually, how do we do the bitmap thing first? I guess we just draw. We could literally just draw circles, and it's not going to be a big deal. Or we could just tag. We could just add to an array. I mean, it's the same thing. A bitmap is an array, so it's like a texture 2D, and we're writing to the pixels, maybe. Or just an array of coordinates is probably just the same. So, okay, let's first do bitmap trace. So the first step is take a bounding box, or a texture 2D full of black and white data, binary data. Points. I mean, it's literally a 2dim array with booleans. That's a texture. That's a 1dim texture, right? It's a 1-bit texture. Yeah. Take a 1-bit texture. Find the edges of the texture, where the contrast, where the changes meet, where the white and where the false and true data meet, with the resulting edge data simplify into a polygonal shape. That's actually all we have to do. Cool. So I have defined a shape as an array list of points, and points as Bezier control points. So this is going to be a shape bitmap trace, taking a texture, or we could call it like a Boolean array called a bitmap. Literally a bitmap. Wow. This is probably correct. Don't comment what I did. And then I would need a function called simplify, and then we'd need to describe that. So let's do that. Shape. There is this relax control points. I don't think this is what I want anymore though. Let's get rid of that. I suppose simplify could be a property of shape. Nah, let's just leave it out here. Sure. Okay, let's do some logic for this too. So what is simplify? Simplify means we need some float tolerance, yes. So take a shape for each start at the first and last points and recursively find the furthest point from the line segment between them. Correct. Yes. That's exactly right. When all points are within tolerance, when all remaining points are within the tolerance, no. If a point is within tolerance, remove it. When all points have been processed, return the simplified shape. Yeah. Fun, 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 fun. Okay. So naively, we should just do the whole canvas every frame when we do this. So I could say like Boolean array map, stroke map, or like, yeah, stroke map, and say stroke map equals new Boolean width and height, and then if drawing update, if mouse is not pressed but we are drawing, we finish stroke. Else, if we're not drawing and mouse is pressed, begin stroke. That should be end stroke. It doesn't have a very good like language server, this thing. So let's flip these around so that they make chronological sense at least. If we're not drawing and mouse is pressed, begin stroke. If we are drawing and mouse is not pressed, end it. Hey Tony Chopper, how's it going? So when we begin, we say drawing is true, we say stroke is a new, we don't need to do this anymore. That's no longer a thing. Okay, and then if we are drawing, then we say I guess what we would do is we would let's ask if there is a way to do bitmap operations in processing. We might be able to use like add bitmaps processing. Let me ask, GPT probably knows how to do this. Okay. Is there a way to, using the GPU, draw, I mean, this would be like compute shader land. Do a compute shader style operation in processing such that I can add a circle of black pixels in the current mouse position to a buffer texture. Processing supports GLSL shaders, and you can achieve this using a fragment shader with a pgraphics buffer off-screen rendering. While processing doesn't have direct compute shader support, you can accomplish the same effect by rendering to a texture buffer. Create a fragment shader. Hey Kratesh, modify your processing code. Is GPU accelerated and works like a compute shader? Hey, Sarabadi. Resolution, mouse pause. Brush radius. Buffer texture. That seems pretty reasonable. I've never used shaders in processing. Data/brush. Okay, let's try it. Oh, I don't need that there. And then we don't use stroke map anymore. I don't think we need to do the pixel density thing at all. Okay, sure. Let's see what you got. We don't need this anymore. Where is that pixel density? We don't need you. Create graphics requires size to use P2D or P3D. P2D, please. File data brush frag is not accessible. I think, oh, hang on. This needs to be inside of that. Let's try again. Hey, 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 hey. But what we probably want to do is do circles between. Oh, it's kind of janky and slow, if I'm being honest. Why are you so slow? Let's ask. What's slow about this operation is there any shader setup code that could be moved out of the draw loop? Yeah. Okay. Yes, please. That's better. I agree. And then over here, temp begin draw. We don't need to do this. We're going to take mouse pause. Resolution goes out of here. Brush radius gets out of here. These two go up. I don't know if that matters. The temp goes away. I guess we set up the temp somewhere else. Temp is up here. Yeah, that's what I would have done. But you need to define it first. And then here we say temp equals. Yes, that's what I would do. But first make sure this is like that. Connotation coding? I don't know what that means. And then this. What is wrong about this? I don't think we need pixel density. I think that's just fine as it is. Thank you very much. Begin shader. I'm not sure why we would put that there, but let's leave it as it is. That's better. Sweet. Okay, you go away. That's better. Ah, super fast. Still feels a little, maybe not great. So instead, I think what we want to do is whenever the mouse has moved too far, we want to draw circles all the way across to smooth the difference. So like there, we skipped over a bunch. So we want to look at the delta between the current mouse position and the previous. So this is like, it's this part here we want to do every time, I think. This is called stamp. And this would be the mouse position. This is not Unity. This is just processing. But I'm using Copilot through VS Code. We want the previous and the current. So p vector prev mouse pause. And then in draw we say prev mouse pause equals that. So p vector mouse pause equals that. Int dist equals that. For int I equals 0, I is less than dist, I plus plus, stamp at, we want to lerp between the two. So p vector dot, is it lerp? Yeah. Between prev mouse pause and mouse pause. And then I'm imagining we've got like the different, how does this work? Start, end, and then the t value. That's easy. It's like I over dist. And you can cast this to a float. And then this becomes pause, and then you pass that in. Okay. Terrible. Why is this wrong? You tell me. Why is this not joining all of these stamped circles together when I call stamp multiple times in each draw loop? Copying back to buffer texture only once the end of update stroke, but each stamp call reads from buffer texture. I see. You need to call you back to after each stamp. Okay. So this here has to happen inside of the loop. I was hoping not to do that, but ooh. Okay. Give me more frame rate, please. Oh, damn. That's great. Beautiful. So cool. I wonder if I can do pressure sensitivity. Hey, Baha Mohammed. Okay, so how are they doing that? Show me the code. Show me the code. EV. What is EV? Add event listener. It's an event, but where did I get the event from? That's the whole sketch. So P is just that value. So all I have to do is take that, put that in my setup function. Oh, is that a JS thing? Ah, but this isn't JavaScript. This is Java. I could switch to JavaScript mode. You need more of the Ani. Well, if that's what you want, then for a little while, I'll give you it. I have to take out my headphones in order to do the accent. Okay, it's so hard. Unless we're talking about things that he is, talking about more frequently, like doing push-ups or doing the flex of the muscles, getting into choppers and things like that. It's kind of hard otherwise to talk about, programming, because he's never talked about that, He's just never, it's not in his vocabulary. I don't really know what it is to code. So we have this pressure. That's right. He went to Mars and he lost all of the oxygen in his brain with his eyes popping out. Dispatch touch event. Override the built-in method. I don't know what this is from. This is Android. This is for the Android. We've got the import motion event. But we're looking for Windows here. We're not looking for Android or JavaScript. Tablet library help. Pen pressure issues with the tablet library and OpenGL. It's the time to ask the question. Hello guys, first let me say I love processing and the Coding Train channel. I watch the most. Having said it, there's a wonderful library written by Andres Colubri named Tablet. Alas, this library only works with the Wacom tablet. I think this Java library can handle it. You mean generic Windows 10 stylus events, OS stuff, right? Not a special tablet peripheral. Maybe we can grab this Java library. jwinpointer.jar multi-touch and stylus pen input events on Microsoft Windows 10 for Java. It's a Java library for retrieving and distinguishing between mouse multi-touch and stylus events. All right, that's enough of that. Okay. So the question is, how do I get this into my program? As far as I know, it's only a single Java library available that gives access to both multi-touch and stylus events for Windows. For ease of compilation, it's been packaged as a single .jar file, contains necessary DLLs. Hey, Roman. Doing okay. Yeah, I'm assuming I'm going to need it. Let me just download this real quick. 2 megabytes. We'll be here a while, chat. All right. I'm just going to grab it and chuck it right here. Now it's inside of data. There is something else we can do, which is if we go to processing, there may be a way to just import the library directly. Because there are libraries. Import library, manage libraries, tablet. So this is the library that we were looking for. Well, that the other person was mentioning. I mean, I've got a Wacom tablet, so I'll just use that one. Is there a way to get like the examples for this? Wait a second. I gotta open. One sec. Open the documents folder. A, B, C, D, E, F, G, H, I. Okay. I wonder what hardware I/O does. Oh, it's already installed. Okay. So, how do I use libraries in processing? This is tablet Andres Kolubri. Bro, is there not documentation for this? How do I know how to use it? Oh, okay. Oh, great. Oh, I love that. Let me guess. Okay, that's not what I was thinking of. How did we get from tablet to sprites? That's weird. Brother. Oh my gosh. Abandoned. Not that I need it right now to do what I'm doing. It's kind of fine to just keep pushing on anyway. We've got the winpointer.jar thing. Maybe we could try to do that. One sec. drag the jar file into the processing IDE and it'll just do it. Okay. You sure, buddy? Oh, it actually did do something. Code jar. Okay. So it knew what to put it. And then what? And then you just import it? Wow. Is that how you do that? Libraries must be installed in a folder named Libraries inside the Sketchbook folder. Or do I just like refer to it? Do I don't even have to import it? How does it work? I have a .jar file that I want to reference in my processing sketch. I dragged it into the IDE and processing placed it in a code folder. What happens now? But how do I know like how to address it? Let's have a look. Oh, the .java file? Ah, right here. Oh, sweet. Okay. Then I get rid of these. I press go. Bow bow. The type string is ambiguous. What? There's no string in that. Okay, well, I've clearly done something wrong. I guess I could try putting it in a folder called libraries and just see if that works. Okay, didn't even like doing that. What the heck? Because it's open right now, maybe? Hmm. Is that right? Because I don't have... It's not going to be here. And then what's the point of the code thing? Like, this exists for a reason. It did this on purpose. So I think we just leave it for now. We don't need it in this moment. I'll just comment this out. Let's move on. String is ambiguous. What are you talking about? Where is... There's no string. I never do that. Did I do something wrong with my everything? $19? There is no 19 in simplify.pde. What is happening right now? Could it be no? Bro, there's nothing in the entire thing that uses this. Huh? What? I'm so confused. Simplify PDE. What the hell? You need a pointer? I'm so confused. What is wrong? Huh? Excuse me. What am I looking at? Is this file like corrupt or something? Now you've got a problem. In the same spot, I bet. Okay, so it's something else that I'm doing wrong somewhere else. Maybe I pasted some empty string somewhere. Brother. I don't know what I did wrong, chat. That all looks really good to me. Do I need to say public? Naming conflict. Okay. I don't think so, but how did I literally corrupt my application? What? What? Used by another process. Where? What else is using it? Processing's not on right now. What the hell? What is happening? Get out of here. What the heck's going on? The yak is being shaved really hard right now. I have no idea why this pointer... Is it because Windows is trying to do some stuff with it? Get out of here. Try again. Who's modifying this file? I don't know what's happening. There's nothing open in my taskbar. Bro, I can't end the stream. I can't do anything. What the hell? Today has gone on a tangent. I got no idea. Well, I can't get rid of this file. I want to keep that one. Let's keep that. Let's... I like this. Let's keep that. Let's keep that. And then let's delete everything else. I don't know. Who knows? Brother. So like if I just delete it, get the same problem at the bottom of this. And if I just delete this, we get the same problem at the bottom of this. So if I just delete this, same problem at the bottom of this. So if I just delete this, same problem at the bottom. I literally can't do anything. I can't do anything. because of this issue. And it literally won't run. Hey, what a way for our work to be cut short today. There must be something in the library that defines string. That's my current theory. And I can't remove the library somehow because of the way that it is. I don't have any way of knowing what other processes are using this file. So I'm stuck. Chat, what the hell do I do? Just work on Insignia instead? Is this the universe telling me what to do? I don't understand why I can't delete this. It's open in processing, but processing is closed. Processing is open in 3 different places as a background process. Well, it is called processing. Holy moly. Get out of here. Hey, works. Okay, we're back. We're back. So, let's get rid of you. Let's get rid of you. Let's bring you back into a reasonable spot. And, so we have our image buffer, and our image buffer is drawing a really nice like a bitmap. And at the end of this, when we're finished, we want to save the simplify the bitmap. Convert. So bitmap trace is this, and this doesn't take this anymore. It's going to be taking a buffer texture, which is a type of P graphics. And then I want to know, is there any way to do this on the GPU? Probably not really. Okay. we're fine. Let's just do it on the CPU. Okay. So we're doing this all the way across, but that's not going to give me a... That's not going to give me an edge. Will this give me an actual edge with clockwise ordered positions? I'm assuming the left and right, the opposite sides will be next to each other as it scans over axis. Yeah. I mean, if you're just going to give it to me. All right, so when we finish the stroke, we say shape trace shape equals bitmap. Now I want to draw the shape. Whoa, look at that. Wowzers. Oh, it's getting very heavy. Lovely. It's actually kind of working. Cool. But we're still quite a ways away. I'm not even sure how we did that. Sure. Oh, because the buffer texture is getting added to every time. So every time we do this, the shape is attempting to draw itself based on the current buffer texture. It's trying to draw a shape out of everything. So as long as they touch, it can do that. Yeah, so once we do this, we want to clear the buffer. Okay, so the question was, how does it know to sort the pixel vertices clockwise? I copied and pasted the suggestion that it gave me. It had some algorithm that it described. So let's read through it because it's exciting. So we find, I'll make this a bit bigger for you. Find the first edge pixel. So we just go all the way through, and then as soon as we have this thing called isEdge, and it just says, I guess, if this is not that, or that is not that. I guess this is just I'm assuming that's just a color check, comparing the two colors. So yeah. Y times bitmap width plus X is just getting the current pixel. So like, let's simplify that down. So if the current color is not the color next to it, or the current color is not the color below it. It's just looking in front and below in this part, but it could also return false if we're outside of bounds. But I think it's not for neighbors. It's just checking forward and down because it's passing through all of it from top to bottom. So it just needs to check the frontier, I think. Don't ask me why that's acceptable, but it seems like that's all it's doing. Because it doesn't check behind it. It doesn't check index -1. So if it's an edge, then we start there and then we can just keep going. We break as soon as we find one edge pixel. Then we have all of the north, south, east, and west directions. And I think we just crawl from the next one until we find a next non-edge the next edge pixel. And then we move in that direction, check the next edge pixel. Move in that direction, check the next edge pixel. And we just keep doing that until we go back to the original point. Yeah, there we go. That's fun. So it's literally doing... It's doing this. It's a little guy, a little agent. And what he's doing is he's got, you know, this shape here, or we can do it underneath. And he's saying, oh, found one. Are you an edge? Are you an edge? Are you an edge? Are you an edge? Yep, you're an edge. Okay, next edge. Okay, are you an edge? Are you an edge? Are you an edge? Are you? Oh, next. Okay, are you an edge? Are you an edge? Are you an edge? Oh, okay. Are you an edge? Are you an edge? Are you an edge? It's just doing that every time, and so it's doing this little like all the way around until it finds all of the edges and comes back to where it started. It's good, except it's not, what it's not going to do is ever find this. It's never going to find this. it's going to be a much more expensive check to do it the other way, because I think what we'd have to do is find all of the edges and sort them into separate shapes by removing and adding them from lists. So you find every edge pixel in the whole thing. This is my strategy. Find every edge pixel in the whole thing, put them in one big list. Start with the first edge. As you go, navigate through all of the edges that it connects to, remove them all from the array. When you finish that operation, the remaining edges are from a different shape. Do the same process with the first thing in the array now, the next thing in the array, and then eliminate all of those from the array. And whatever's left is another new shape, etc. The only problem is we can't break from that. We'd have to essentially check every single edge to do that, which means checking every single pixel. So there is no first edge pixel. Let me ask the question and see if it agrees. Would it be if I wanted to allow for there to be multiple shapes in this input, would the best strategy be to store all found edges, would be to sweep the entire image, store all edges in an array, and eliminate them as we find individual shapes and remove them whenever we connect one edge chain back to itself. Restart the process with the remaining edges as a new shape, etc., until all edges are removed. Mark visited pixels. Continue scanning the image for unvisited edge pixels. Start a new trace from each unvisited edge pixel. Oh, that's fun. That's even better. So what it's doing is saying, that's actually really cool. Let's do that version. So that version is like this. It's saying, okay, here's my shapes, right? I got two shapes. The second I hit even one edge, I go, whoa, 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 whoa. Let's do our little sweepy, sweepy, sweep. Okay, I'm finished. Keep on going. If I've seen these before, don't worry about it. Seen it. Whoa, whoa, whoa. New edge. That's not part of the old chain. Let's keep going. So let's try that. So I'm on board. Automatic flower garden planter. It's so fun when we know how it works. Let's read it. So it gives us an array of shapes. Good. An array list in this case. While true, Find all shapes by scanning for unvisited edges. I'm not sure I can read this. Do this forever, but then return shapes. Where is this? This while true goes all the way to here. No more edges. Okay. So start X. We do this every single time until when we go through visited, there's nothing left to do. I know what it's trying to say. Okay, so we need an array of shapes. I think shapes now need a color. That'll do. Yes, please. Whoa! So cool. Dude, it's killing my brain though when I don't know why it's doubling up like that. Wait, what's drawing this? Get out of here with that. I don't want to see that. Wow. But I'm still getting overlap that I'm not really understanding. Is it just that the colors are touching each other? Maybe. Bro, it's so slow. It's so cool. Okay. So, we aren't simplifying them yet. Let's do that. when we finish this, we trace it. And then we want to say for shape S in shapes S dot simplify S equal, you can't modify it while you're doing it, right? Yes. Okay. So how we do this? I was gonna say that's pretty ambitious. How do we simplify a shape? We already did this, right? So I think I might want to write this myself. I'm kind of excited about this one. Okay. So take a shape, start at the first and last points, and recursively find the point furthest. So for yes. And then recursively find the point furthest from the line segment. So fine. For each of the points, P equals points dot get I. Can I really not just say points at I? This is an array list, that's why. But does it have to be one? A shape has an array list. I think it needs an array list because we don't know how many points there are. We have to add the points. Therefore, this can be an array, but we won't know yet when we're sort of like eliminating. We might need like a hash map or something to determine which ones we're keeping or not keeping. Or we have like simplified points, which is the points that we keep. So instead, instead of having points, we could just say input dot points. In fact, that's the same thing, right? Because it's a by reference. So we call this I points. And then we have O points, input output. So for each of the points in input points, the P is that, okay, and then distance is, we need a line segment distance check. So we need public float dist to segment, and it's point A, point be, in fact, it probably should be p vector, but whatever. That's probably right. I know how to do this check. You have a line segment. You have a point. The perpendicular edge is what we're looking at here. So you're trying to find this distance or whatever. And so the way to do that is you do that. It's just the way to do it. Let's walk through it so that we understand. This is, you take away these, so you get the deltas, b minus a, x minus a. So this is the distance between, this is b, this is a. So you take this distance and this distance. And then you find the magnitude. I don't know what square is. Is it the absolute value of the positive? You square this, right? And just take the, it's always going to be positive. I don't know what mag is though. Magnitude of the square. Then you take the dot product of AP, AB, which is a to x. And then you divide that by that. If this, it means that it's on the line, I guess. Projection, distance projection, t, multiply. Doesn't matter. This is one of those library functions that I don't need to know how to do. Someone can explain it to me another time, but I don't need to know it right now. Okay, so we get a distance from the segment. And if the distance is greater than the maximum, then the maximum is the new distance, and the furthest index is now the current I point. Good. So we're going to do this until, so progressively find the furthest point between them. And then we can keep, we can say simpler, we can say O points dot add first point. And then I think what we can do is essentially ignore every, no, we can't do that. Let's go back to our logic here for how we did it. So when I say this is my start point, let's make this a lot nicer. This is 0, this is n, this is x. This is our first point. So we've got this one just now. Now we need to go between O and X. We treat this as two separate lists now, I think. And we say, okay, what's the distance, the greatest distance between these two? So now track back from this has to be recursive, but I'm not sure. I mean, it has to be. Because you want to do what we just did, but with the sub list of where we started from. So let's take this and this all the way to here and put it in a function called find extreme. It should be first index. And then we find the point. So we do, what's the operation? We have these 2 points. We check all of this. We find the furthest from it. Now that we've done that, we do the same thing with everything from first to the end. Until okay, so we have our recursive. We don't need to do this because it's going to modify the collection anyway as it goes, because it's a reference type. So we should be okay to just keep doing this. And then I'm just going to call this find extremities. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. So we want to do it from start index to the new end index, which is furthest index, with I points, O points, tolerance. Yes, exactly. Hello.
I'm just gonna put shots together some stats.
Okay, sure thing. Is your feet okay? Do you want me to go pick them up later?
What's that
Okay, you sure?
thing? I wanna see if that
Okay. Hi. Is this gonna work? Did I just solve this? I think we just need to say O points dot add P. No, we do it here. No, it's I points dot get furthest index. If has to be greater than tolerance. Oh, I see. Yes. Right. So if we, yeah, this is an early return. Early return if we didn't find anything far enough. Okay. I think this might work. How exciting would that be? The only thing is, I think O points being like the fourth thing in the array is kind of a bit weird. But other than that, oh, I can't tell. We need to provide the tolerance. It should basically provide us the same list. It's a little ugly. So the tolerance has to be at least the size of the radius, radius. I mean, no greater than the size of the radius. If I say 1, does that do it? Okay. So it's not great, but it does give us something at least. And there's something in our simplify that's a little confusing to me. If it's a closed shape, I guess it's fine if we always keep the first and last shape, the first and last pixel. That's no big deal. So find extremities, get the first point, get the last point. First is this, last is that, max dist, furthest distance. This is the tolerance. So the max dist is fine. Is there something I'm not thinking about, which is kind of like, I mean, it might bend my brain a little bit, but if this was a banana, would it be any different? Let's say this is the first, this is the last. I think it should be fine because we'll pick like this one. And then between those will be this one. And then it'll probably be this. And then between this and this would probably be like this. And then between this and this would be like this. And then between that and that would be that. So it'll do it right. If assuming we got it right. I'm just not sure about what I'm looking at here. These slices all the way back are not happy. Is it because we're adding them in the order that we find them, not in the order that they occur in the list? Yeah, that's why. So let's do, instead of adding them to an O points, let's do Thanks, Ian. This doesn't seem right. I guess we could do like a proper insertion. Like sort as we add it. I think it's just add, but you need to have a second parameter for where you want it to be. Processing array list add. Bro. Is it just add at index processing? Okay, the index first. Furthest index is what we're looking for. I think that's better. Yes, give us nothing. Oh. That's not right. Furthest index. Does add it before or after? How do you do? As long as they're sorted, it's not enough to just stop whenever you see one that's bigger or smaller than yours, right? You kind of need to, let's have a think. If I got a bunch of numbers and I want to add it right here, okay? And my guy is this long. I say, am I bigger than you? Yeah, bigger than you. Yeah, bigger than you. Yeah, bigger than you. Yeah, bigger than you. No, so I stop. So it's if less than. Wow, I was right. Okay, I was wrong. 0. Okay. Maybe we just need to do that. Wait, if we're never greater, then if we're never lesser than, I guess we could just say O points to add. But what does this break do? Break only breaks us out of that. So we need like a bool added equals false. Not that I need to do that, but just nice to be consistent. Yay! Hey. Okay. So now let's bump up the buffer size. You know it. Okay. Doesn't like that. Interesting that like the second we put a number that's not 1, it doesn't work. Isn't that weird? It works with a value of exactly 1. It's very upsetting. It's super annoying. All right, let's have a look. The distance must not be right. That's weird. Okay, I mean, these look really reasonable. 30, 40 pixels, 70. Sure. I mean, that's great. If I say like 10, why would that be any different? You get literally nothing. Not even, it doesn't even add one of them. So something's going wrong here. Let's have a look. I mean, tolerance really just gets used here. Is it that this is wrong? Surely not. 0, size -1. I mean, that seems pretty reasonable to me. We're passing in I points, start index, end index, first, last. We're going to use them there, so maybe that should be like... Ooh, hang on a second. Whoa, 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 whoa. Oh, we always need to add the first two. That's what you do. Ooh. Something's happening. Ah, but we can't add... Well, yes we can. Why not? Why can't we just add the first and the last one? Point stone size is never going to be 0 at that point. I feel pretty reasonable about this. I points dot get index of O points at I for all of them. Otherwise, add that one. What's wrong with this? We never call added, it looks like. Are we early returning too early? If max distance. Is our distance to segment function wrong? That's not good. Finding extremities between 0 and 0. That's also really bad. Oh, no. It starts with 0 and 114. Max distance is 1.4. That can't be right. Ah, the order is wrong. That goes last. Oh. Yay! Look at that. I'm not sure what these... I'm still not sure what the dots are, though. That's what's getting me. Those original dots are a little confusing. Maybe it's the... because we're still drawing the buffer. We probably shouldn't really even be drawing on the... I don't know. Okay. Well... That's exactly what I wanted to do. Oh my gosh. Little wonky. Because the thing needs to be this needs to be radius divided by 2. I think we'll start with that. This is actually insane. I did not think we'd get this result today. Not a game jam. It's just I don't know how to explain it. It's just a drawing tool that I want to build. I want to know how many points we reduced it to. Yeah. Simplified from 1 to 2. Very good. From 1179 to 43. Wow. So are we getting a bunch of little rogue shapes? Is that what's happening? When I draw a straight line, there's all these little 1s to 2s that show up. What time is it? It's 5:20 p.m. So we need to say if traced path dot size. What is traced path? Traced path is a shape. Greater than 3. Cool. It simplified from 619 points down to 14. That is so cool. It's still got a bunch of shapes that that are like, I guess, hangers on, just like little tiny little extra shapes. It's probably okay that we have them, but it's not nice that they exist. That would be fun. You want to see zooming, chat? It's so cool. Yeah, this would have a bunch of shapes in the corners. Actually, I wonder if there's some sort of anti-aliasing that's happening that we can turn off. That might actually solve it. Nah, still got him. Not as many though, maybe? I mean, I might do some concept art in Insignia for this. So zooming here is tough because you need matrices, I think, and I'm not very experienced with them. I guess when we draw the shapes, we have this begin end shape. If this points.size is greater than 2, it shouldn't have a point size greater than 2. Let's just ignore that. And I don't want to draw the points right now. Or really ever, but whatever. Okay. So, that's right. It will be doing that. The graphics thing, like this begin shape and this end shape, there's kind of like you have to remember to scale the draw matrix because when I do this begin shape and end shape, it's applying these vertices. So I think what I want to do is just I think I need to do something here that's like it's just like it's a processing thing. It's not I'm not really worried about anything else. Let's just check, for example, like handle stroke. Just going to do some refactoring for a second. Okay. It might be easy once I've segmented everything out. Sweet. Okay. So okay, so when we scroll, Oh, I see. Oh my gosh. Oh my god, that was easy. Okay, we just need to make it so that when we draw, it factors that in. So it's close. It's close. It's close. The only problem is the bitmap, as it relates when we draw it. It needs to relate. Oh, are the tiny shapes visible? I don't think so. Let's start again, and I'll draw a really complicated shape that's quite small. I mean, I'm not seeing anything. What? I'm just going to assume that is reasonable. Weird. It's going in the opposite direction. I guess I have to subtract. But you would think if I just subtract this and add that, it would be fine. Ah, there we go. It's moving a little further than the delta, unfortunately. A bit slippery. It's so cool How we can just sit here and inspect them like this. Like, that's what I drew. That's the thing. I think we'd afford to go higher fidelity than this. You can see that's the start and the end. We could just not add the end point when we do the simplify. That way you just won't have it at the top. Sweet. Okay. So now yeah, exactly. Gosh, you can get the level of like fidelity you get. Like when you simplify, we're simplifying down from 569 points to 22, and the radius that I'm simplifying at is 20. It's 1/20th. Like even if I do it at 0.01, that's still gonna cut out. I wonder how many. More than half. I mean, that's not great. Okay. Well, that's not great either. We could probably say 0.01, but max, whichever is bigger, 5 or that number. Okay, 3 or 0.5. I mean, it can't be 2, right? Why does it look... It can't be 1. Oh, that looks really smooth. We must be... I do have middle mouse drag. We already have that. You think it should be a constant regardless of radius? I mean, we could do that. We could say it's like 3. Or 1. Maybe 1 is the number we want. I guess there would be a lot of points where it's less than 1. I'd like to see the points now. Yeah. Yeah, I would say depending on zoom factor. Let's see what happens. Well, right now they're always being drawn at the same zoom level. So we can't do this just yet. Let's call it 1 and move on. Hey Tartar Gravy, how's it going? So, we want to, when we store these, when we do the bitmap trace, we take the buffer texture, and previously this was very straightforward because we just had the pixels and we were just pasting them where they go. But now we want that buffer texture to be kind of like scaled and transformed. to the new position. So when I think we want, for the way that the player has drawn, let's think about it. When we do this, when I draw that line should be like that line, no matter what. And I guess it's fine to draw it on the screen here in absolute position, but now we need to, it's not that we want to scale and transform the texture, it's that we want to scale and transform, once we've processed the texture, all of the output points. So when we simplify, or when we trace the bitmap before we simplify, maybe. After simplifying. I don't think so. I think we want to simplify. Well, if we simplify if we simplify before, then we don't have to do the zoom. Yes, I agree. Yeah, I agree. I agree. I don't really know what the logic should be for that. Okay. Maybe this just works straight away. Nope. Whoa. I think all the control points are getting mucked up. I think you would think this would be just right straight away. It's not even close. Oh, hang on a second. I have to draw them differently as well, based on the view. Well, let's just agree with it. Okay, hang on a second. This is fine, this is fine, this is fine, this is fine. So it's not wrong. I think it's just that when we shapes.draw, dude, my neighbors are blasting music right now. My brain cannot think. I'm so disoriented. Push matrix, translate, scale, translate. Why am I translating, scaling? Is this right? Is this right? I don't think it knows. This might just be one of those things it's not very good at. Because this is all correct. So I think I want to see the current zoom. What's the percentage? What is it actually doing to do this? Zoom times 100. What is NF? Two decimal places. Yeah. Okay. So that's 2, that's 1. So when I draw a shape and we rescale, I think instead there's a better way to do this, which would be to have a rescale for the points as well. I know that's wrong, but so when zoom is 2, it goes half. That's good. Okay, I think we can, I think it's not a bad idea to do that, but I also think I want to do, well, I want to say what the zoom is, and I want to say what the translation is. The view pods. And maybe view pods can just be view from now on. Is it good music? It's like R&B. This song, it's from Mario Galaxy. Damn it, man. What am I doing wrong here? This is from da, 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 da. Yeah, I think it's from Odyssey. You're right. You're right. It's Odyssey. I thought it was Galaxy for a sec. I knew it was Mario. I wasn't really paying attention. Okay, so like when I zoom in, the view is going off this way, right? It was Cascade Kingdom, I think. Yeah, I think you're right. So let's debug. Let's just debug this really quickly. Draw crosshair at origin. Draw a line from origin to view. Now, when we start the game up, I think I want for the view to be yeah. I'm a little confused. I mean, the view, this dot should always be in the center of what I'm looking at. Should it not? divided by zoom. Something's wrong. Something's way off. Yeah, I think you might be right. I think this is like that. Then you scale by zoom. And then you translate by something like that. Or even, why do we need to do this? I don't understand. Maybe it was better to translate after we zoom. What happens if we never translate? Then actually we should set this view to be 0, 0, right? Start with that. And when we zoom, right now it's zooming in and out of the origin. So actually, what we could do is always translate by minus width and minus height. We always want to do that before we start doing anything else. I guess not. Okay, let's take it away. When I zoom, I mean, it makes sense that that's doing that, right? It makes sense that we'd be scaling towards that. But when we scale, we want to scale towards where the mouse is, which means we need to incorporate the view into that, which is what we've already been doing, right? Like right now, we're just scaling in and out of this. And if I draw here, maybe we do it without the view, and then we can sort of just go from there. So the first thing is, okay, if I draw something here, why doesn't it stay there? Because view is 0, 0. Okay, so when we go to point and we rescale, when we subtract from the pos the view, nothing bad should happen. So then something's not quite working when we I mean, that should just be straightforward, shouldn't it? Unless we have to draw the shapes outside of the matrix because they're already scaled. No. Oh, I'm so confused. I'm so confused. Because when I scale... No, that's right. That's right. I should draw them after I've scaled. Because they should just be smaller. So that's fine. That's fine. When I zoom in on this... What I absolutely hate is the way that the... like, what's that red line doing right now? From view X to view Y. When you scroll, you're still changing the view. Oh! Yes, 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 yes. I think you're right as well. Okay, let's just get rid of this altogether, this part. Just for now. Okay. Perfect. Okay. Let's try it with multiple now. Okay. Now, interestingly, it adds to the zoom. Every time I draw. Ah, that's because it's doing it for all the shapes. We want to do it after that. Okay. Yay! Okay, great. Ah, fantastic. That's exactly what we want. Can you tell me a story while you make this apps? Because I want to draw stuff. Okay, so... All right. This handle stroke stuff, I think I'll do it before I push the matrix. That way we can still see the shapes as we're drawing. Vector. Oh. No, that's not going to do what you think it is, but Bro. What's resolution? What's resolution? Sick. All right. And now we just want to maybe see if we can translate by the view. We'll just see if that does anything. I would expect to have to translate by a negative view. Wait, it's working? Except sometimes. Looks like I have to add or subtract something when I create the shapes. I have to subtract the view from their position, I guess. What does this sub do? Is it sub that from that or that from that? Yeah, I think you're right. The red line should always be pointed to the corner of the view. The red line, well, hang on a second. Let's look at what the red line actually is doing. It's not, the red line is just doing absolute pixels difference. So I do have to multiply by zoom. I think that's a given. As the view goes up, so negative. There we go. Well, as far as we know, then it's right. As far as we can tell. Oh, so there is something is happening. When we zoom out, it's not always in the corner. When we zoom in, yeah, it's not always in the corner. As we zoom out, for some reason, there's a drift. Why is there a drift? And you're right, it is the drift. That's the whole problem. Let's take this for now. Try that. But it's still slipping. If we let this be what it already is, and then go back to the middle center mouse button, we could just look at this. And say, fix it. Fix that. I mean, that looks way better. That looks like what I expect. Oh, much better. The panning's now right, but the drawing's way off. So when these two are about the same, it's pretty good. When we drag out, the amount that it's dragging out is the drift distance. So that's going to go all the way over there somewhere. Yeah. That's going to be up there. Yep. So when it's perfect, it's right. But there seems to be a delta between the end of the red line and the top left corner of the screen, although these are supposed to be precisely the same thing. There's the view offset. I mean, no. I think the red line is pointing where it's supposed to. What I mean is that the view shouldn't be slipping from the view. Origin should be always in the top left, but somehow it's not. This causes shapes to slip when rescaled by that same delta. Wait, but the user said, so weird that it thinks in words to itself. Read. I mean, let's try it. Oh my gosh. Nailed it. Nailed it. Wow. So cool, man. I just made one. No, this is better than them. This is going to be much better. Yeah, I am trying to recreate Macromedia Flash 8. So what? What about it? Sweet. Oh, I'm so happy with that. We gotta commit there. That's adds first demonstration with bitmap to vector, zooming and panning. Wow. And then I gotta go home. I mean, I gotta end the stream. I got it too. I'm trying to replace it. That's the point. Like, in about 5 more minutes of work on this, I'm gonna get Scrubby Zoom in, where you can zoom in and out just by dragging left and right. Flash doesn't have that. You know? Like, I gotta go. I'm going to make this awesome tonight. Actually, I will be live again a bit later. Maybe we'll keep working on this. I don't know. We'll see. Let's find someone to read and get out of here for now, though, because I gotta have dinner. Well, we don't have the merging yet. We don't have the merging yet, but it seems pretty... It seems like we will be able to do the merging, no problem. This was like startlingly not as hard as I thought it would be. I know we had GPT to help us a lot, but like, we all understand the algorithm, you know? It wasn't actually nearly as complicated as I expected it to be. Let's raid Jitspo. All right, thanks pals. I had a lot of fun, hope you did too. If you like the content, check out my YouTube channel, I guess. I'll be posting there probably this weekend with a new tutorial. It'll be a continuation of the programming tutorial. So if you got lost today, you won't be lost next time. That's it. That's the stream. As always, I've been Adam. You've been the Pixel Pals. This has been the Indie Tales Game Dev live stream. Until next time.